Hi everyone, today we're looking at Module 1 and we're focusing on lessons 1 and 2. Lesson 1 focuses on exponential notation. And our student objectives are students know what it means for a number to be raised to a power and how to represent the repeated multiplication symbolically. Our second objective says students know the reason for some bases requiring parentheses. Now remember in class we talked a little bit about how parentheses change the grouping of a base with its exponents. We want to make sure that we're paying close attention to those ideas. So what we want to focus on is the notation, and we're going to remind ourselves that when we add 5 copies of the number 3, we notate 3 plus 3 plus 3 plus 3 plus 3 as equal to 5 times 3. We took an expression that's fairly long and we write it as kind of a short summary of that expression. So if we multiply 5 copies of the number 3, we want to notate that 3 times 3 times 3 times 3 times 3 as equal to 3 to the 5th power. Some examples include 5 to the 6th and 9/7 to the 4th power. Note how those parentheses around the 9/7 mean that that entire piece of my expression is my base and should be repeated 4 times. All of these are examples of exponential notation. This can also be used with a negative base. So if we had the number -2, for example, to the 6th power, the parentheses are used to isolate that negative symbol. Moving on, we're going to look at Module 1, Lesson 2. And this covers multiplication of numbers in exponential form. Our first student objective says students use the definition of exponential notation to make sense of the first laws of exponents. Our second objective says students see a rule for simplifying exponential expressions involving division. And our third says students write equivalent numerical and symbolic expressions. So if I need to multiply by different powers of the same number, for example, 3 to the 5th power times 3 to the 7th power, I'm writing 3 times 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 3. And altogether, I have 12 copies of the number 3. This also works with different bases. If I said, for example, 6 to the 6th power times 4 to the 9th times 4 to the 3rd times 6 to the 14th, I can combine the exponents with the similar bases. Lastly, I can use exponential notation to simplify two exponents with the same base written as a fraction.